Today we're going to be looking at adding and subtracting rational expressions, which means that we're going to have to be finding a common denominator. When you multiply, you just multiply the top times the bottom. But when we add and subtract, we have to find a... So, for our first problem, we need to find a common denominator. So we got to factor first. So 3x minus 3, that's the first one, and x minus 3, x minus 2, that's the factors of the second one. Let's see. So then the common denominator would be 3x minus 3, x minus 2, because they both share this one, so I just have to list it once. Okay, now you multiply each fraction by what is currently missing from the common denominator. So let me write it like this first. Sorry, that's minus 3, x minus 2. Okay, so this first fraction is missing x minus 2 over x minus 2, and the second fraction is missing 3. Now you're asking, I know, right now, why did I list it twice? Well, because x minus 2 over x minus 2 is really just 1. 3 over 3 is 1. I can't change the value of an expression, so I can only multiply by 1. So that's why I had to list it, that's why I had to list it over itself, okay? And it makes the denominator common, which is what I need. I need the common denominator. So, this top one needs to be FOILed. So x squared minus, because it's minus 2x plus x, so minus x minus 2 plus 15, all over 3x minus 3, x minus 2. Okay, so simplify the numerator, x squared minus x plus 13 over 3x minus 3, x minus 2. Now if you can, you try to simplify, factor the numerator again and see if anything cancels. But in this case, there are no factors of 13 that make negative 1. So this is the final answer. Okay, now subtraction is very similar, but we just have to remember one extra step, and that is we have to remember to distribute that negative sign once we have the numerator simplified. So start the same way, factoring. X minus 2. So the common denominator will be the same as it was for the previous problem. And then multiply each fraction by what's missing. This will be the same basic idea as before. So let me rewrite the problem. Okay, so now I'm going to multiply this one times x minus 2 over x minus 2, and I'm going to multiply this one times 3 over 3. So when I go to write it as one fraction, once again I have x squared minus x minus 2 over 3. This gets very tedious to write, but you just have to do it. Minus the whole thing, or I can go ahead and write as one fraction. Put a minus sign right there. 3x plus 15. Okay. If I'm writing it as one fraction, I just have to write the denominator once. So I guess I kind of could have moved that over. So now I need to simplify the numerator. So I have to distribute this negative to everything inside. So this is really negative 3x minus 15, because I have to distribute it to both terms inside. So x squared minus 4x minus 17 over 3x minus 3x minus 2. Once again, see if there's any way to factor the numerator. There's not, because there's no factors of 17 that make negative 4. So x squared minus 4x minus 17 over 3x minus 3 x minus 2. Okay, now, I think in my other, on my notes in Edmodo, this says plus right here, but it is minus. So this should not be plus, it should be minus. So if you're looking at just the key to the notes, I think it's wrong right there. Okay, so give these a shot, work on some on the back, and then watch the second video of the ones on the back. So I'm going to make 2 separate videos. So try some on the back, and then watch the second video. Denominator. So let's quickly remember how we do that with just numbers. So if I have 6 and 10, if I factor that, that's 3 times 2 and 5 times 2. So my common denominator would be, okay, so the common denominator would be 3 times 5 times 2, which is 30. Okay? Even though they both have 2, I just have to list it once. However, if I was doing 6 and 20, which was 3 and 2, and 5, 2 and 2, then it would be 3 times 2 times 5 times 2 again. Because the 2 and 2's would be this 2, but because there's an extra 2, I'd have to list it again, which would be 60. And that would be the common denominator for 6 and 20. So the same is going to be true as we look at these problems with binomials in the denominator. And you'll learn in trinomials, but you'll see how it works.